idea that number theory typically has a lot of remainder theorems. Okay. Mota there are 5 remainder theorem: the basic remainder theorem, the Fermat's little theorem, Wilson theorem, Euler theorem, Chinese remainder. All of them are not difficult, they're just a little bit complex. Then there are ideas like last 2 digits. Then there are ideas like, binomial expansion in this. Although I don't take binomial expansion as a part in numbers, I'll take it as an idea for algebra. There is also an idea of multinomial theorem. I will not get to that part right now, but then understand that number system is very densely packed with a lot of theorem, a lot of understanding, and the idea that it's very mechanical. There aren't many questions that CAT tests these days. But anyways, let's learn the idea, because number theory will help you become a better manager, will make you eventually better human being, because you'll be able to learn how to crunch numbers, you'll be able to learn many things. So having said that, I think keeping that perspective in mind, number theory becomes really interesting. ठीक है, चलिए start करते हैं. Let's start the session. So what I am typically interested in doing for today's lecture is I want you all to be, pay attention to the idea of Fermat's theorem. Now, this typically will include something called as a Euler number. Now, there are people who would like to call it Euler, but typically it is called Euler. And this, my friend, is Fermat's little theorem and not Fermat. Okay, now having the English out of the picture, let me tell you what exactly that means. Suppose there is a number x that is divided by another number n, and x is raised to the Euler number of n. Now for our comprehension purposes, you can call it Euler also, Fermat also, I don't care, but it's always better to know the real meaning, so that when you go to abroad next, sometimes in the future, you'll not be, they'll not mock you. Typically, when this type of a situation happen, when x is divided by a number n raised to the Euler number of n, and you have to keep this in mind, x and n will always have to be co-primes. Now what do this mean? That their HCF will always be equals to 1. In that condition, remainder is 1. That's it. This is Fermat's theorem. This is also Wilson's theorem. Okay. Now we will introduce the idea of Euler number. There are people who would also like to call this as the totient function. Either you can call it a totient function or a Euler number, both are the same thing. Now let's take an idea, let's take an understanding that what exactly do I mean by that. So suppose 7 is raised to the power 12 divided by 13, and I asked you find the remainder. Now first check is that x and n, or the numerator and the denominator, or you can also say the dividend and the divisor, has to be co-prime. In this case, they are co-primes. What is the Euler number for 13? So, just for the time being, I am telling you to remember this thing, that the Euler number for 13 is 12. I'll explain how to calculate the Euler number as well, or the totient function. But at this point, I'll just want you to remember that the Euler number is 13. For 13 is 12. So, according to Fermat's theorem, the remainder has to be 1. Because if you see, x has been raised to the Euler number of the n. Does this make sense? And I hope it does. Now the idea is, how do we calculate the Euler number for 13? First thing first. First, let us try and understand about Euler number, and then we will proceed to what happens when the denominator is not a prime. Suppose it is a composite. So we'll look into it, but step by step. So how do we calculate the Euler number? Euler number is the number of co-primes less than the given number and 1? Example के तौर पे अगर let's take the Euler number of 8. What will be the Euler number of 8? Let's, एक बार करते हैं, आराम से करते हैं. All the numbers less than 8, let's list them. 1, 2, 3, 4, 5, 6, 7. That's it. We don't, include 8 in this thing. Less than 8. Obviously, for the time being, I'm just taking 1 out of this business. 2 obviously will get, have a common will be common factor of 8, so 2 gets eliminated, 4 gets eliminated, 6 also is common with 2, so 6 gets eliminated. So all the primes, or the co-primes rather, all the co-primes less than 8 will be 3, 5, 7, and please remember you have to include 1. That's it. So if somebody asked you what are the Euler numbers of 8, so these are the Euler numbers of 8, so 1, 3, 5, 7, and somebody asked you what is the Euler number of 8, how many numbers are, so Euler number of 8 is 4. Now typically you can write it like this also, E of 8 is equal to 4. Okay, this is the idea. Now obviously this is a very time consuming way to calculate the Euler number. I hope you realize that. In the exam, obviously, we cannot list down the numbers and then, calculate. So let us devise a technique, shall we? So yeah, let's devise a technique. How to calculate for Euler number. Correct? So we take this example only. E of 8, or you can also, if you want to write it, you can write it like psi of 8 as well. Okay. Just remember one thing, you have to know the prime factorization of 8. Now, obviously in algebra 400, that is the, not the algebra 400, the numbers 400. I have taught everything how to do the prime factorization, but for just this thing, I'm gonna do it once again. Prime factorization of 8 will be 2 cube, and that's it. You will not find any 3, you will not find any 5, will not find anything, you will just find 2 cube. So the technique says, when you write the number n in its prime factor form, a raised to the power p, b raised to the power q, c raised to the power r, and so on and so forth, the Euler number will be given by n multiplied by 1 minus 1 by a multiplied by 1 minus 1 by b and multiplied by whatever is, whatever primes occur in the prime factorization of that number n. Hope that makes sense. Now let's quickly do this for the number 8 itself, because 8 is the number that we've been playing along for quite some time. So let's do it quickly for 8. So let's find the Euler number for 8. You can also call it the totient function for 8, which is going to be 8 into 1 minus 1 by 2 is 1 by 2. Obviously I should actually do that for the first time. So this is going to be 8 into 1 by 2. This is going to be 4. So this is the Euler number for 8. Hope that makes sense. Now friends, I would want to ask you a very simple question. Okay, and the question is that you have to tell me the remainder of this. You have to tell me the remainder of this thing. Now obviously you will start off by this thing 7 and 14. The first thing that will strike your mind is that, sir, 7 and 14 HCF is not 1, is not just 1. So there are more, there are common factors more than 1. So it is not just HCF has to be just 1. They are not co-primes. They're not co-primes. What do we do with that? Now that is the question. That is the next idea which we will discuss. So let me take a question itself. Okay, let's take the same pattern, 11 to the 97 by, this time let's say 18. What is the Euler number? First thing, is 11 and 18 co-prime? You'd have to see this thing. Obviously they're co-prime. And what is the Euler number for 18? you have to do this a couple of times. 9 square into 2, so that is 2 into 3 square, so 2 and 3 will be there, which means that this is going to be 1 by 2 and this is going to be 2 by 3. This goes away, this is 6, so the Euler number for 18 is going to be 6. Okay, now we also know, we have, in the beginning of this question only we discussed that HCF, we have to make sure that these two numbers are co-prime or not, and they are, because HCF of them is just 1. So what I will do is I'll try to again transpose this thing to a multiple of this thing. Okay, 6. Remember the Euler number, we'd have to transform 11 raised to the power 97 such that I get something to the 6. How do I do that? See this very carefully. I can write this as 11 to the power 6. Now 6 into 16 is 96. So I'll just multiply 11 divided by 18. What exactly does Fermat's theorem tell you? 6 raised to the power anything will give you the remainder as 1. Now if you have to pay attention to just this part, and this part will give you a remainder of, quickly you have to tell me, 11 by 18, remainder is 11. I hope that makes sense. So the entire question can be boiled down to these simpler bits. You can just do one thing at a time and you'll get the answer. Okay, so now for the ones who are here to know that whether we should be skipping something, let me give you an anecdote. Let me tell you what you can skip and what you cannot skip. So we are we are in the month of July right now. So the exact date would be 18th of July when I'm recording this thing. Almost half of July is left. August, September, October, and November is also there. You don't have the luxury to skip anything. You can actually go through everything very swiftly. Now I can totally understand that a few of these things may not make any sense to you, because you'll be like, sir, मेरे से profit and loss तो बन नहीं रहा है, मैं क्या इसमें अपना दिमाग लगाऊं? But think about this. You are here to learn certain things. You are here to learn numbers, number crunching, multiplication, 2-digit multiplication. So in the subsequent videos, when I will be teaching you last 2 digits, I will teach you a very interesting idea that when you have to do the last 2 digit for a number, let's say, when you have to so then you will be left with something like this, 9623. You can't do anything with it. How do you proceed? So you will just use your Vedic math. So 6 3s are 18, you keep 1, 27, 12, this is 9, 39 plus 1 is 40, you will keep 4 there, 18 plus 4 is 22. This is how you get this thing. Okay, and for the ones who want to verify, I don't think I need to verify, but just because this is a YouTube video, I'll verify this thing. 2208. So guys, please see this thing now. These are the things you'll keep on doing in your mind. These are the things. So square of a number, suppose 97 ka square. How do I calculate the 97 ka square? How do I calculate a number like, how exactly can we manipulate numbers? So you'll learn those things in the number system itself. If you want to skip something, maybe skip the difficult questions, not the easy ones, not the ones which you can do like orally. There are certain things that you can do orally. So yeah, I mean, skipping and all, don't do that. If you want to join our courses, you can just do that. There's a link in the description. I hope you enjoyed the session. I hope you learned something, and that's it from me. Somajit signing out.